Hi everyone, welcome back to my series of videos on introductory microeconomics. This video's topic is elasticity. Now, this video is going to be a touch more mathematical than some of the videos that come before it, but don't panic. I promise to take it slow and do my best to explain the intuition behind the math in really plain English. Without further ado, let's get started. Why don't we kick things off by thinking about chocolate, just to ease into things. Last video, we talked about the law of demand. This idea that higher prices for chocolate bars reduce the quantity of chocolate bars that you might want to buy. That's the direction of the relationship between demand and price. As prices go up, quantity demanded goes down. But that relationship has another dimension that we didn't talk about last week: magnitude. How much does a higher price for chocolate bars reduce your demand? Does a 10% increase in prices mean that you want to buy 10% fewer chocolate bars? 50%? 1%? This is where elasticity comes in. Elasticity is defined as a measure of responsiveness in quantity demanded or quantity supplied to a change in one of demand's or supply's determinants. Put plainly, we want to know how much quantity demanded or supplied changes when something important like income or price changes. Demand and supply are determined by a lot of things, as we talked about last week. For example, demand is determined by income, the prices of related goods, etc. When we're talking about how quantity demanded responds to changes in price, we're talking specifically about price elasticity. In this case, the price elasticity of demand. Let's talk about how you would go about calculating the price elasticity of demand with a numerical example. In general, elasticity is defined in terms of percentage changes. If I wanted to know the price elasticity of my demand for chocolate, I would take the percentage change in my quantity demanded and divide it by the percentage change in price that I face. Now, you might be thinking, whoa, Charlie, percentage changes? I don't know how to do that. Take a deep breath. Percentage changes sound scary, but they're not. You probably use them every day. You might say, oh, I have twice as much money in my account today as I did yesterday. Shout out to GameStop. That's a percentage change. You have 100% more money in your account today than you did yesterday. Percentage changes are just a way of defining how much something has changed in terms of how much it was originally. If your hourly wage goes up by 50%, you make 1.5 times as much as you did before your raise. You already know instinctively how a lot of this fits together. All you have to do now is take that instinct and apply it just a little bit more formally. To that end, we can define the formula for calculating percentage changes. Maybe I want to see how Thanksgiving impacted my waistline. If we want to calculate the percentage change in my weight, we take my weight after Thanksgiving, subtract my weight before Thanksgiving, and divide it all by my weight before Thanksgiving. We then multiply this number by 100 to see the percentage change in my weight. So, for example, if I weighed 160 pounds before Thanksgiving and 180 pounds after Thanksgiving because I love cranberry sauce and turkey, the percentage change in my weight would be 180 minus 60, which is 20, divided by 160 times 100. This gives a 12.5% increase in my weight. Okay. That's how you calculate percentage changes. We can apply this formula when calculating price elasticity. Imagine price of chocolate bars goes up from $2 to $3 per bar, and my quantity demanded correspondingly falls from 15 to 10. The percentage change in price is 3 minus 2 divided by 2 times 100, 50%. Prices rose by 50%. The percentage change in quantity demanded, on the other hand, is 10 minus 15 divided by 15 times 100. Or negative 33.3% repeating. I can now calculate price elasticity as the ratio of percentage change in quantity demanded to percentage change in price. In this case, negative 33.3% divided by 50%. That gives negative 0.666% repeating. Well, what does this number mean? Because price elasticity is a ratio, this means that every 1% increase in price leads to a negative 0.66% increase or a 0.66% decrease in my quantity demanded. Well, that's price elasticity. That wasn't so bad, was it? Pretty much just a straightforward application of a couple of formulas. Now, a few notes on this. Because of the law of demand, price elasticity of demand is always negative. An increase in price by 1% is always going to decrease demand by some percentage. For this reason, a lot of economists will drop the negative sign and just talk about the absolute or positive value. It's assumed that the impact is negative, so it's a little bit redundant to say it explicitly. Either way is okay though. I'll follow the convention most economists use and talk about these numbers without the negative, but I'll try to remind you that it's actually a negative effect. Just try to keep that in mind. Okay, the most perceptive among you might have already noticed a bit of a problem. If we switch the order of the numbers around, we get a different elasticity. For example, I said a 1% increase in price lowers my demand for chocolate by 0.666%, right? What if I assumed prices start at $3 and fall to $2? Since my demand curve hasn't changed, that must mean my quantity demanded increased from 10 to 15 chocolate bars. Well, the percentage change in quantity demanded is 15 minus 10 divided by 10 times 100, an increase of 50% in quantity demand. Percentage change in price is 2 minus 3 divided by 3 times 100, a 0.3 repeating percent decrease in price. If I throw these numbers into the price elasticity of demand formula, I find that my price elasticity of demand is negative 1.5%. A 1% increase in price lowers my quantity demanded by negative 1.5%. Well, what gives? These are two totally different numbers. It turns out that the issue is that elasticity changes along the demand curve. If I calculate elasticity using two different points as my quote-unquote starting point, even though I'm talking about the same part of the curve in total, I get different answers. Well, that's not very satisfying. Now, if you're a student in advanced econ, you just use some nice calculus techniques to get around this problem by calculating elasticities instantaneously. But that's way beyond the scope of an introductory microclass. Instead, we have a nice and simple method to get around this problem called the midpoint method. How does the midpoint method work? Well, when calculating percentage changes, you'll remember we divide the difference between the initial and new values by the initial values. When using the midpoint method, we instead divide the difference between the initial and new values by the midpoint between the two values. Let's do this with the chocolate example. Imagine price goes up from $2 to $3. To find the percentage change in price, we take 3 and subtract 2. This gives 1. We then divide by the midpoint between 3 and 2. This is just the simple arithmetic average of 3 and 2. 3 plus 2 divided by 2 is 2.5. So we divide 1 by 2.5 and multiply by 100. Price rose by 40%. What about quantity demanded? We know from earlier that when price goes from 2 to 3, my quantity demanded falls from 15 to 10. To calculate the percentage change in quantity demanded, we take 10 and subtract 15. This gives negative 5. We then divide by the midpoint between 15 and 10. This is just the average of 15 and 10. 15 plus 10 divided by 2 is 12.5. We therefore divide negative 5 by 12.5 and multiply by 100. This gives a percentage change in quantity demanded of negative 40%. We can then stick these into my price elasticity formula. The percentage change in quantity demanded is negative 40%. This is divided by the percentage change in price, 40%. 40 over 40 is 1. A 1% increase in price therefore reduces my quantity demanded by 1%. This is where the value of the midpoint method becomes clear. Before, I got different elasticities depending on whether I started at $2 or $3. We just went through the example starting at $2 with the midpoint method. If you were to work the same example through, starting at 3, and use the midpoint method, you would get exactly the same result. A 1% increase in price reduces quantity demanded by 1%. I think it's best to really think the midpoint method through rather than just plugging numbers into a formula. You'll have a better grasp of it if you really understand what you're doing. However, in the interest of giving you every possible resource, I'm going to give you the formula. We've already worked it through. Here's the final result. Okay, that's enough numbers for now. Let's draw some pictures. You might have noticed that the price elasticity of demand can take values less than, greater than, or equal to 1. We call a portion of a demand curve with an elasticity greater than 1 elastic. When demand is elastic, a 1% increase in price results in a more than 1% reduction in demand. Graphically, an elastic demand curve is pretty flat. You can see from this graph that a small increase in price has a large impact on demand. You can think of, say, shirts from the Gap as being pretty price elastic. If the price of shirts from the Gap goes up by a little, you might consider buying shirts from Old Navy or something. They're pretty interchangeable, so a small change in price might have a big impact on demand. One extreme case of elasticity is perfect elasticity, where a 1% increase in price reduces your quantity demanded to 0. This is represented by a perfectly horizontal demand curve. On the other hand, when price elasticity is less than 1, we call that portion of the demand curve inelastic. When demand is inelastic, a 1% increase in price results in a less than 1% reduction in demand. Gasoline might be a good example of a good for which price is pretty inelastic. Even if the price of gasoline goes up quite a bit, you probably still have to fill up your car to get to work, so your demand probably isn't going to change all that much. The other extreme case is perfect inelasticity, where a 1% increase in price has no impact on quantity demanded. This is a perfectly vertical demand curve. The point I really want to drive home here is that price elasticity measures how much your demand changes in response to price changes. If demand is elastic, demand's response to price changes is greater in magnitude than the price changes themselves. If demand is inelastic, demand's response to price changes is smaller in magnitude than the price changes themselves. Okay, now that you hopefully have a good sense of A, what elasticity is, B, how to calculate elasticity, and C, what differently elastic curves might look like, we can talk about an important corollary to price elasticity: how changes in price change overall revenue. Firms, when acting rationally, there's one of those principles of economics back again, maximize profit. Part of maximizing profit is maximizing revenue. Setting prices to maximize revenue, then, is important for economics. It turns out that whether a price change increases or decreases total revenue depends on the elasticity of demand. This will be easier to explain with a diagram. This rectangle here is the revenue from this price, because price times quantity is total revenue. If demand is price inelastic, a 1% increase in price reduces quantity demanded by less than 1%. This means that increasing price increases revenue. Graphically, a pretty steep curve represents the price inelasticity, and you can see that increasing the price doesn't have a very big impact on quantity demanded. This rectangle, then, gets bigger. This is because of the price inelasticity. The flip side of this should be relatively easy to see. For a price inelastic portion of a curve, lowering prices reduces revenue. On the other hand, if demand is price elastic, a 1% increase in price reduces quantity demanded by more than 1%. This means that increasing prices actually decreases revenue. Graphically, a pretty flat curve represents price elasticity, and you can see that increasing price should shrink the revenue rectangle. The flip side should, again, be pretty obvious. Reducing price when demand is elastic should actually increase revenue. Okay, we've come a long way. There's a little thing to grasp here that's not completely obvious, and that's that a linear demand curve has a changing elasticity as you move from left to right. Imagine we have this demand curve for chocolate, where a $1 increase in the price of chocolate reduces total quantity demanded in the market by 20. Up at the top left of the curve here, a $1 increase is a pretty small change in price in percentage terms, since price is already pretty high, but the change in quantity demanded is huge in percentage terms. Well, if you think about the formula, that means that the elasticity in this portion of the curve is super high. What about the bottom? If we're moving from $2 to $1, that's a huge percentage change in price, but it induces a relatively small percentage change in quantity demanded. So this portion of the curve is very inelastic. Since we move from the very elastic to the very inelastic as we move from left to right, there's a unit elastic point right in the middle of the curve. You can see then that elasticity is different from slope. This curve has a constant slope and a changing elasticity. Okay, great. Now that the math is out of the way, let's quickly talk about a few things that might have an impact on the elasticity of demand. Here's a quick and dirty summary. First, how available close substitutes are. If the price of apples goes up, your demand will be much more elastic, which means your demand responds more to the increase in price, if you can switch apples for oranges. If close substitutes are readily available, you're more likely to have elastic demand. Second, how much of a necessity the good is. Like I said before, gasoline might be pretty non-negotiable for your day-to-day life. The same might be true of electricity, or heat if you live in Canada like I do. Third, time horizons and market definitions. How we frame the analysis will have an impact on elasticity. For example, demand for a broad category of goods is much less price elastic than demand for a narrow category of goods. For example, your demand for food is much less elastic than your demand for apples. Similarly, over a long period of time, demand tends to be more price elastic. If the price of gasoline went up tomorrow for one day, you probably wouldn't drive less. If gasoline were persistently more expensive, though, you might think about selling your car and buying a Tesla, or taking the bus. 2 more quick points, and then we can be done. First, I talked earlier about how elasticity is just a measure of how one thing responds to a change in another thing. We don't necessarily have to talk about price and quantity demanded. 2 other common elasticities in economics are income elasticity of demand, which measures how demand for a good responds to a 1% change in income, and cross-price elasticity of demand, which measures how demand for one good responds to a 1% increase in the price of another good. Calculating these is pretty straightforward. You just have to calculate the percentage change in quantity demanded of the good and divide it by the percentage change in whatever you're calculating elasticity with respect to, whether that be the good's price, the price of another good, income, etc. The other point I wanted to make before finishing up is that all of the analysis in this video can be extended to the supply side. In the interest of not making this video any longer than it already is, I won't go through supply elasticity in excruciating detail. I wanted to go really in depth on demand so that you'd get a pretty good sense of how to think about elasticity without muddying the waters by adding supply. But it's really a pretty trivial extension. All of the formulas, all of the insights about reading graphs, it's all applicable to supply as well. And that about covers it. Thanks for watching. I hope you found this video helpful. As always, I'm happy to answer any questions you might have in the comments down below. If you want to ace your econ course this semester, or you're interested in seeing more videos like this one, please consider subscribing. Most of the people who watch my videos aren't actually subscribed. Thanks again.